Okay, I apologize for the way that I sound. I've been completely stopped up and coughing. But anyway, so I'm going to try to get through this. This is what we're doing right now is called networking. And this is not like what you would do on social media, right? We're not finding new people, but whatever. Networking in this case is all about like logistics, and it is all about connections. So let's say you have a snowplow, and there's a neighborhood, and you've got a bunch of houses. There's a house, there's a house, there's a house, and there's a house, there's a house, and there's a house. And let's say they're all on the same street, right? Or like a U-shape, like 3 streets. So each of these dots represents a house. So this right here is a house. We call that a node. Sometimes they'll call them vectors. I don't like calling them vectors because a vector is a specific thing. So a vector is something that has a magnitude, right? It has a length, but it also has direction. So that's why in Despicable Me, a vector was the guy whose crimes had both direction and magnitude. So that's because that's what a vector is, right? It's not just a line. It's a line in a specific direction. So this might be 5 miles, but it might be 5 miles, what is this, east, northeast, something like that. So it's got a distance, but it's also in a specific direction. That's a vector. What we're looking at is more specifically called a node. And a node is each of these little points, right? Each of these houses is a node. These houses are connected by a street or more than one street. And those streets, or these connections, are usually called edges. So this is a node, and this is called an edge. It's basically a path, right? So anything could travel along these edges. We could be talking about a kid with a paper route. We could be talking about internet service. We could be talking about a snowplow in this case. So you have all of these connections, and so maybe there's a street connecting like right there too. Well, if you're just talking about paper routes, we don't really care about that because the kid could actually go from here to here to here, down to here, and over to here. All of the papers will have been thrown, and he doesn't need to mess with this right here at all. But it depends on what you're doing. So if you're plowing the street, like you're a snowplow, then you are more concerned with all of the streets getting plowed. So you would want this to be plowed, this to be plowed, this to be plowed, this to be plowed, and also this. So the whole point of like networking and this whole point of this particular unit is making routes and networks and paths and circuits that are more efficient. So this is actually a really, really big deal, especially if you have a company like UPS, right? The more time you spend backtracking and going over streets that you've already been on, the fewer packages you can deliver and the more gas you use. So it ends up costing a whole lot more because you're wasting time going back and forth over the same streets. So here, let me skip ahead. So if you're a UPS driver and let's say you need to deliver a package here, 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 and here, and let's say there are streets here, maybe there's not a street there, there's a street here, there's a street here, maybe there's a street here, maybe here, and then back this way. So this is kind of a weird looking thing, and normally you'd be like, well, there's no way streets would look like that. But if you pull up a map, there are quite a few that are a little bit messed up. So your job as a planner for UPS might be finding the most efficient route. So maybe it's not efficient to do these 4 right here, and then now you're started back here again, so you still got to backtrack again this way, maybe this way, maybe this way. But then you still got to go back the same street. So now you've gone over the same streets like 2 or 3 times in some cases. And so you're wasting gas, you're wasting driver time. So what you would want to do then, your job as a UPS planner, as a logistics person, your job is to figure out the most efficient route that'll get all of the packages delivered with the least amount of waste, So you might have something like, you might go this way instead. You might start there, go up to here. Maybe you'll go this way, around these ways, this way, back up to here, and then back to there. Notice that we haven't gone over a single street twice. We've passed, like this one, we passed this house twice. But that's okay. We didn't necessarily need to stop there, but we haven't gone back and forth over the same things. So that would be a more efficient route. So that's the whole point of logistics and planning, and that's the whole point of this little networking and graphs type of a unit. So on your worksheet, we had this weird thing called the Konigsberg Bridge. So what this is this is an actual thing. So there's a city in Europe, I forget what country it is. It's Netherlands or Prague or Czechoslovakia, I don't remember. Poland, maybe? Anyway, we'd have to look it up. But anyway, these people apparently have nothing better to do. I think it's actually winter there a good bit of the year. And so they basically were like, well, wait a second, we've got this river, we've got these two islands in the middle. And so they started, so this is like, let me draw, so this is a bank over here. Let me make this a different color. So you've got a bank over here, you've got a bank over here. These bridges are in the middle of a river. Or, sorry, the islands are in the middle of a river. And these bridges connect them from the banks to these little garden islands. And they've got little gardens and things that people want to, like, walk around and see. Because over there, it's not hot enough to burst into flames, so people actually do stuff outside, like, for fun, on purpose. So unlike here, where, you know, if you go outside half the year, you burst into flames, because the streets are literally almost lava. Okay, so the problem then is they said, well, wait a second. So what if, like, is there a route where we could cross every single one of these bridges only once and still see both of the islands, right? So if I did that, what I just did is I crossed this first bridge, the second bridge, I want to cross it down, cross these two bridges, but this bridge over here is left out, right? So then I go, okay, well, wait a second, that didn't work. Let me try something else. So I'm going to go, okay, well, what if I started on this island? Oops, wrong thing. What if I started on this island, I went there, I could go up, go across, go here, go here, go here, go here, but now this one is missing. So they started looking at this, and it became like a national pastime or a pastime of that city. So people have been trying to solve this problem for a really long time and trying to figure out, well, is there a path without going over to some, like there's probably a bridge over here somewhere, but without using those, only using these two islands and their bridges, is there a way to pass over each bridge only once? And begin and end at the same place. So if I started here, how could I go over all of the bridges, but only one time, and still end up right back where I started? So here's where I started, and I end right back there. So that's the Konigsberg Bridge problem. The whole problem is trying to figure out how I can get across these bridges only one time, not crossing the same bridge twice and end up back where I started. So then the question is, well, is this possible? And if so, how would you do that? So that's problem number one on our worksheet this time, is this Konigsberg Bridge problem, and that's the whole point of that one. Okay, so this was an introduction to kind of the basics of networking and route planning, and we'll talk more about it later, but hopefully this clears it up.